And rational expressions were just fractions that had polynomials in it. And we learned how to simplify them. So we learned how to simplify them. And the process of simplifying rational expressions required you to factor. So again, factoring is a very important aspect of this whole unit on rational expressions. And then after we learn how to simplify, we learn how to multiply. And there's a lot more with factoring involved. And in this case, now there's more cancellation processes that occur. We can cancel things diagonally, as we've done in several of these examples, as long as the expressions in the parentheses are all the same. And there's one very noteworthy warning that I mentioned was that just because you have two terms that are the same in the numerator and denominator, that does not make it sufficient to cancel them out. They have to be both enclosed in the parentheses, and then you can cancel them, just as you have something like this here. 2x minus y, 2x minus y, they're both enclosed by parentheses, so you can cancel those two things out. But if you don't have any parentheses around them and they're the same, you cannot cancel those things out. Just to keep that in mind. So we talked about multiplying, and now we're going to go on to the next phase, which is dividing. Dividing rational expressions. And so dividing rational expressions is analogous, similar to dividing fractions. And if you remember how we divide fractions, we have to keep, change, and flip. So this also will apply here. We keep, change, and flip. So example here, I got 6 x squared y to the 4th divided by 35 a squared b to the 5th divided by 12 x cubed y cubed all over 7 a to the 4th b to the 5th. Okay, so now we have this new thing here where we're dividing, right? But if we divide, we have to keep this guy here the same. We change the division to multiplication and we flip. We flip the last one. So this will be 6x squared y to the 4th all over 35a squared b to the 4th multiplied by 7a to the 4th b to the 5th power all over 12x cubed y cubed. Okay? And now division becomes multiplication. It's just that we flip the second fraction. And then from here, it's just multiplication. We've done this already. So that, like I mentioned before, adding and multiplying, multiplying and dividing rational expressions is actually the easier of the operations compared with addition and subtraction, which we'll see a little bit further down the line. So now we can cancel, right? We can cancel things that are common factors. So for example, 6 here goes into 12 2 times, and this is left with the 1. The x squared divides x cubed. You take away those 2x squareds to 2 x's, but I'm left with 1x. The y cubed cancels out 3 of those y's, so I'm left with 1y. The 7 goes into 35 5 times. The a squared cancels out the 2 a's inside a to the 4th, which I'm left with a squared. And then b to the 4th divides b to the 5th, and I'm only have 1b left. So then what's left over in numerator? Well, I have a y that's left over, an a squared that's left over, and a b. So I can write this as y a squared b, or we usually put the a squared at the end, at the squares at the end. So it should be a yb a squared divided by, and we do that because it's just notationally speaking. And what else here? Oh, pardon me. This is b to the fifth. Sorry. This is b to the fifth, not b to the fourth. So b to the fifth power is actually, that cancels out with b to the fifth up here. So there should be no b left. There should be no b. So I'm left with only y in the numerator and an a squared in the numerator. And the denominator, all I have is if you notice, you have 5 times 2. Remember, we multiply the things across, right? We multiply them across. So 5 times 2 is 10. And I'm left with an x. So this should be my final answer here. All right. So that's how we start to divide rational expressions, and we do so by keep, change, flip, which becomes multiplication. And we know how to multiply rational expressions. So nothing extremely new out of this. Let's look at another one. What if I have 12x squared y squared minus 24xy squared, and this is all over 5z squared divided by 4x cubed y minus 8x squared y divided by 3z to the fourth. Again, we keep, change, and we flip. So this becomes 12x squared y squared minus 24xy squared divided by 5z squared multiplied by 3z to the fourth. And this is 4x cubed y minus 8x squared y. So we keep the first fraction, we changed the division to multiplication, and we flipped the second fraction. So we keep, we changed, and we flipped. Okay, and now we realize, wait, can I factor? Before we cancel anything, let me factor as much as I can. So in the numerator, I can factor for the first fraction, I can factor out a 12, an x, and a y squared. And when I do so, I'm left with x minus 2. And this is over 5z squared multiplied by 3z to the fourth. And then in the denominator of the second fraction, I can factor out a 4. I can factor out an x squared and a y. And when I do that, I get x minus 2 as well. You see that? So factoring, definitely helpful here. And now I can cancel out the x minus 2's. Those go away. What else goes away? The 4 goes into 12 3 times. The x takes one of these x's from the x squared. One of the y's takes away from the y. The z squared just becomes a 2. And I can't not factor anything further. So then what do I get? Now I multiply everything across, right? I have a 3, I have a y, I have a 3, and I have a z squared. So 3 times 3 is 9. Y is left, and I got z squared. All over, I got 5, I got x. So this is 5x. So 9yz squared over 5x. That should be your final answer. Okay, any questions about keep, change, flip? Any questions about multiplying, dividing rational expressions? It's really just piggybacking off of multiplication. And again, factoring is a huge part of this. All right, so let's look at the next example here. Okay, so what if I get this? I get 6x squared minus 7x plus 2. And this is over 3x squared plus x minus 2 divided by 4x squared minus 8x plus 3 divided by 5x squared plus x minus 4. Okay. So here we have lots of trinomials that we need to factor. Okay, so I'm going to call these 1, 2, 3, and 4. But before we do that, before we do anything, let's always keep, change, and flip. Okay, just to set ourselves up. 6x squared minus 7x plus 2. We keep this the same. We go from division to multiplication, and we flip the second fraction. All right, so now I want to do this. I'm going to call this trinomial 1, trinomial 2, trinomial 3, and trinomial 4. So for number 1, how do we factor 6x squared minus 7x plus 2? So this is already good practice for your quiz. How do you factor this? Anybody? Where do we start? Anybody can give me the first step?
You can factor by grouping.
Yeah, we have to factor by grouping, but how do we get there? We need 4 terms, right? So we need to do 6 times 2, right? Which is what? 6 times 2 is 12, and then what happens? After you do 6 times 2, what happens? We get 12, and then what do we ask ourselves? What adds to 12? What multiplies to 12 but adds to -7? And Samir says correctly, -4, -4x, -3x. Good. So then this becomes 6x squared minus 4x minus 3x plus 2, right? And then we can group factor by grouping. We can factor this, factor this. You can factor out a 2x, and I'm left with 3x minus 2. Factor out a -1, and I get 3x minus 2. So this becomes 3x minus 2 multiplied by 2x minus 1. So that's my first factorization, and I have to do this 3 more times. Again, we have to become very proficient, extremely proficient with factoring. So this becomes, the next one is 3x squared plus x minus 2. So what do I do? Same thing, right? 3 negative 2 is -6. What multiplies -6 but adds to +1? We can do this 3x squared plus 3x minus x minus 2. Then what do? Factor by grouping. And this becomes 3x. X plus 1 minus 1, x Did I do that? Oh, sorry, this should be a 2. Sorry, that's a -2. So this should be a -2 here, and this is x plus 1. And then you get x plus 1 multiplied by 3x minus 2. So boom. Here we have 1 and 2. So far, so good. Next, 3. Our third trinomial here is 5x squared plus x minus 4. Same thing. 5 times -4 is -20. What multiplies -20 but adds to +1? One of them has to be a positive 5x and then subtracted by 4x. Same thing happens here. Factor by grouping. I can take out a 5x and I'm left with x plus 1. I can take out a -4 and I'm left with x plus 1. That equals 5x minus 4, parentheses, x plus 1. I got the third one, and then finally the fourth one. The fourth one, 4x squared minus 8x plus 3. Multiply 4 and 3 and positive 3 together. I get 12. What multiplies to 12? But that adds up to -8. And I get 4x squared minus 6x minus 2x plus 3. I can factor the first two, factor the last two, and I'm left with 2x minus 3, minus 1, 2x minus 3, and that equals 2x minus 1 multiplied by 2x minus 3. So all I did was I factored, and factored, right? Okay, so now once I've factored everything, now I can continue this, right? So I'm gonna put a little star here, and I'm gonna continue where I left off. So now I can replace all these different trinomials. I can replace them with their factorized expression. So then it's gonna look like this: 3x minus 2, parentheses 2x minus 1, divided by. This is gonna be divided by x plus 1, 3x minus 2. This is 5x minus 4, x plus 1, 2x minus 1, 2x minus 3. And then what do? We cancel the ones that are the same. So we have all of these cancel out and they become ones, right? When you divide. And when the dust settles and it clears up, what's left? The numerator only has a 5x minus 4, and the denominator has a 2x minus 3. And I cannot cancel anything further because they're two completely different expressions. So therefore, this is my final answer. 5x minus 4 over 2x minus 3. Okay. Simple enough, guys. It's really just multiplication, which is like an extension of multiplication. Division is really just an extension.
Are we going to have this kind of question in quiz today?
Oh, definitely not. It's much simpler. It's things that we did prior to the spring break. The quiz is not stuff that we
Because
did.
the factoring took a little longer time to do. So I don't know if the quiz time will be enough for us to finish up.
Yeah, I'm not giving you this. So you're not going to be factoring 4 different trinomials. You're going to be factoring one thing. Like
Are we going to have a division method as well?
No, there's no division here. It's
Okay.
just, it's strictly factorization.
Okay, gotcha.
Yeah,
Thank
so
you.
you have to know all the factorizations that we've done, right? We've done trinomials, we've done difference of perfect squares, difference of perfect cubes, different sum of perfect cubes. I get to know those. But of course, I'm not gonna test you on all of them because it's just a quiz. So just a couple of them.
Okay, thank you.
Yeah, as you can tell, it takes a while, it takes some time, but eventually your speed as you start doing more of these is going to get faster and faster. Eventually, again, this is just like instructional purposes, why I'm going step by step, but slowly you yourself will find speed with this. Okay, good. So so that's division. What if we do a little mix of the two? A mixture of division and multiplication. So what if I have something like this: x squared minus x plus 12 divided by x squared minus 6x plus 5 divided by x squared plus 3x minus 28 divided by x squared plus 5x minus 6 multiplied by x squared plus 12x plus 35 divided by x squared plus 11x plus 30. So now we have a mixture. We have division and multiplication. So the first thing is, let's take care of the division first. Remember, with division, you have to keep, change, and flip. You don't flip this one because there's no division sign. The division sign is only next to this one, so we only flip that one. So let's do that. So we're going to keep the same thing here, x minus x plus 12 divided by x squared minus 6x plus 5 multiplied by x squared plus 5x minus 6 over x squared plus 3x minus 28 multiplied by x squared plus 12x plus 35 divided by x squared plus 11x plus 30. And again, we have a whole bunch of trinomials here, but it's not going to take as long as what we did in the previous example. Here, the factorizations are all trinomials that have the a value equal to 1. The leading coefficient is 1. So we don't have to do the whole AC method. So it should be quicker. So what multiplies to 12 but adds to negative 1? Well, one of them has to be negative because, wait, let me see, x squared minus, yeah. So what multiplies to positive 12 but adds up to negative 1? So anybody for the first one? Negative 4 and 3. That's interesting because it looks like it's not factorable. So this might be a typo. The thing is, negative 4 times 3 gives me negative 12. So let's keep that in mind because I'm getting this is an example from the textbook. So this might be a typo, but let's keep that in mind because I don't think it's possible to produce a negative number when you add the two numbers, but give you a positive number when you multiply them. Because either the two numbers are both positive or they're both negative. But if they're both negative, there's no two numbers that when you add them that multiplies to 12 give you a difference of negative 1. So just keep that in mind. How about the next one? X squared minus 6x plus 5. Can we factor that? So see, this is both positive, right? Positive 5. So that means that both numbers either have to be positive or both of them have to be negative. Because my number inside here is negative 6, they both have to be negative. So this should be what? X minus 5 and x minus 1, right? Because the negative 1 times negative 5 is positive 5, negative 5 plus negative 1 is negative 6. Next one, x squared plus 5x minus 6. what multiplies to -6 but adds to +5? So it must be x plus 6, x minus 1, x squared plus 3x minus 28, -28. So one of them must be positive, one of them must be negative. They add up to +3. So it must mean that I must have x plus 7 and then x minus 4, because 7 times -4 is 7 times -4 is -28. You add 7 and -4 and you get +3. And then the last one here, last two, x squared plus 12x plus 35. What multiplies to 35 but adds to 12? Well, it's going to be x plus 7 and x plus 5. And then you get x squared plus 11x plus 30. So it should be x plus 5 multiplied by x plus 6. Now, in all estimation, I believe this should be a minus, not a plus. So make that correction here. There should be a minus. That's the only way this would be possible. So then it would be correct, Sierra. It should be x minus 4, x plus 3. Yeah, yeah. So that's a typo. So this is just a little typo. Okay, so now when we have all of this factored out, what cancels out? Well, the x minus 4s cancel. Boom. The x plus 5s cancel. The x plus 7s cancel. The x plus 6s cancel. The x minus 1s cancel. And I cancel all of them. So see, after all that hard work, things cancel out really nicely. And then the result is x plus 3 over x plus 5, x minus 5. And that should be the final answer. All right. Any questions about factoring, using factoring to simplify division or multiplication of rational expressions? Well, I'm glad, David, that you have no questions. Great. So no one has questions about this. So again, factoring, guys. Factoring is an important aspect that you have to develop and master, not just for this class, but for any other math courses that you'll take as you go along. Now we're going to head into the more difficult kind of operations. So multiplication and division are a little simpler because all you have to do is factor, cancel, factor, cancel. That's pretty much the extent of it. But when we add rational expressions, it takes a bit more time out of us, I guess. So when we add rational expressions, we have to remember we're dealing with fractions. So what is the requisite, or what is the requirement to add two fractions? What must be the same? Does anybody remember?
The denominator.
The denominator. What about the denominator?
They must be the same.
Right, they have to be the same. So the requirement is that the denominators must be the same. They must be the same, and this is no different for rational expressions. It's just that when we do rational expressions, it's a bit more complex than what we're normally used to. And what do I mean by that? Well, let me give you an example, okay? So let me give you an example of two rational expressions that I want to add. Hold on. Yeah, let's say I want to add this, okay? I want to add a minus 3 over a squared minus 5a plus a minus 9 over a squared minus 25. So the first thing we notice off the bat is that the denominators are not the same. So the denominators are not the same, or I should say unlike denominators, right? But the requirement to add or subtract, particularly here is to add, is that we need to make the denominators the same. Now, how do we do that when we talk about rational expressions? We know how to do that when we talk about just regular numbers, right? So how do we do that here? So to make the denominators the same, I must find what's called the least common denominator, the LCD. So I must find the LCD between a squared minus 5a and a squared minus 25. I must find what is the least common denominator or the least common multiple. This is also known as the LCM, least common multiple. Now, how do I do that? Well, let's take a look at each of these denominators. Yes? Someone say something? So how do we figure out what the least common multiple is? Well, we have to study both of those denominators a bit more. A squared minus 5a. What happens if I factor it? So again, factoring comes into play again. What happens when I factor the first denominator? I can factor out an a, and I get a minus a times a minus 5, right? And then look at the second one, a squared minus 25. If I factor that, what does that become? That becomes a minus 5, a plus 5. Now, what I want to do is I want to find the least common multiple of these two expressions. What that simply means is, what would it be? What would it be? What would be the multiple that includes all of them, all the factors that these two have, and all the factors that this one has? What would be the expression that contains all of these factors at once? So as you can tell, a minus 5 is in both of them. So both of them have a minus 5 in them. That's good. But the second one does not have an a, but the first one does have an a. So we have to include that a. So this is the LCD again. This is the LCD. And then in the second denominator, it has an a plus 5 as a factor, but the first one doesn't have an a plus 5. So we have to include it. So we're basically including the things that the other one doesn't have, in addition to including what they do have in common. And this is my LCD. Again, the LCD is not the same thing as the GCF. People confuse those two things a lot. It's not the same. The GCF between a squared minus 5a and a squared minus 25 would be the greatest common factor, which would just be a minus 5. That's the common factor. We're not looking for the common factor. We're looking for the least common multiple of them both. Which just means include everything that's not in the other one. That's it. So the LCD here would be a. It would be a multiplied by a minus 5 multiplied by a plus 5. That's my LCD, guys. So I found my LCD. That's step number 1. Great. Now, what's step number 2? Is rewrite fractions. Rewrite denominators as LCD. So going back to our original problem, right? We got a minus 3 all over a squared minus 5a. We're adding this to a minus 9 over a squared minus 25. And now what we did was we broke it down by factoring it first. So a minus 3 all over a times a minus 5 plus a minus 9 all over a plus 5, a minus 5. So now we asked ourselves this, guys. If you look at the denominators, they both almost look like the LCD, don't they? What's missing from the first denominator to make it the same as the LCD? What's missing? All you have to do is look. So in this first denominator, we have a and a minus 5. The LCD is a minus 5, a plus 5. So what's the only thing that's missing in order for this to become the LCD?
A minus 5.
Well, it has an a minus 5. But what is it missing?
I mean, a plus 5.
So it's missing an a plus 5. So what do you think we're going to do? We're just going to multiply it. We're going to multiply the top and the bottom by a plus 5 because that's what it's missing, isn't it? It's missing this. That's exactly what we do with the fractions that we're normally accustomed to. When we have different denominators, right, we find the LCD or the least common multiple, and we multiply top and bottom by the missing number or the missing factor. And in this case here, over here, what's missing from here? A plus 5 is here. A minus 5 is here. What's missing? An A. If it's missing an A, I'm going to multiply the top and bottom by A. So we rewrite denominators as LCD by multiplying each denominator by the appropriate, or in this case, you can think of it as the missing factors. The missing factors for the LCD. That's why the LCD must be identified first. Then you know what to multiply each denominator by, so you get the LCD. So look what we get now. The denominator is the LCD, a times a minus 5, a plus 5. The denominator here is also the LCD, a times a minus 5, a plus 5. Now the denominators are the same. We did it. They're the same. Now, once we have the denominators the same, we have to take care of the numerators. So again, we're multiplying these fractions here. We're multiplying them. So this is really going to be what? A plus 5 multiplied by a minus 3. And I'm really going to have a minus 9 multiplied by a. Sorry, these almost all look like a's. So again, we keep the denominators exactly the same, guys. Pardon me. The denominators now doesn't change. The denominators are exactly the same, so we just keep the denominator all together. But what we have to take care of now is the numerators. So be mindful of what you're doing. This is a plus, right? Remember what we do first? We do multiplication, parentheses first. So we have to expand everything here first. And then we can distribute this. So let's put this all together. We get what? We get a squared minus 3a plus 5a minus 15 plus a squared minus 9a. And all of this is being over a times a minus 5, a plus 5. I'm pretty sure you guys are missing multiplying and dividing, aren't you? You see now this is just one problem. We're not even done yet. But this is like all the work that it takes to add two rational expressions together. And now we have to combine like terms. So we have a squared, that's 2a squared. We have negative 3a plus 5a is 2a. Minus 9a is negative 7a. Minus 15. and I'm left with a times a minus 5, a plus 5. So step 3 here, guys, was to keep denominator the same. And combine numerators. So I combined the numerators, which I did. And now the very last step is if it's possible. So if possible, simplify. And what I mean by simplify is factor and cancel. So the idea is, can I factor? So you see here, this has a whole bunch of stuff. It has multiplication and it has factoring as well. So there's a lot of things going on. So sometimes you can't do step 4. That's why if possible is there. So if possible, can I factor it? Well, let's try. What multiplies to 2 and negative 15? 30, negative 30. What adds to negative 30? What multiplies negative 30 but adds to negative 7? So you need to do what? So now I have to factor this by itself, right? 2a squared minus 7a minus 15. And can anyone tell me how to break this down? 2 times negative 15 is negative 30. What two numbers multiply to negative 30 but add to negative 7? So one of them has to be negative, the other one has to be positive. Anybody got that?
Negative 10 and 3.
Yeah, that's right. Negative 10 and 3. So this becomes 2a squared minus 10a plus 3a minus 15. You can factor out the 2a and you get a minus 5. You can factor out the 3 and you get a minus 5. So this becomes a minus 5 times 2a plus 3. So then, yes, you can do step 4. So this will be a minus 5 multiplied by 2a plus 3. And then this becomes a times a minus 5, a plus 5. Then the a minus 5s cancel. And what's left? 2a plus 3 all over a times a plus 5. And I'm done. I cannot cancel anything else. This is exactly what it means to add these two fractions together, or rational expressions. That's what it took us. That's the cost of adding. So adding, as I told you, is much more complicated than multiplying or dividing, oddly enough. Okay, so that's adding. And now subtracting is the same idea. It's just that you have to be mindful of one little thing. And that little thing is a lot of times neglected. And therefore, a lot of people make the same mistake. So there's one little thing that you have to take care of when you subtract. Again, it's pretty much the same thing as adding. It's pretty much the same thing. So subtracting rational expressions. So let me give you good one. All right, so let's look at one. So what if I have this? X over x plus 4 minus 4 minus x over x squared minus 16. What does this equal? So the first step, right? first step is to identify the LCD. What's the LCD between x plus 4 and x squared minus 16? So what would help is to factor, okay? X plus 4, that's the first denominator. Second denominator. X plus 4 is just x plus 4. You can't really do much to that. But the second denominator, x squared minus 16, isn't this x plus 4, x minus 4 by the difference of perfect squares? And knowing this, now can't we think about what the LCD would be? Remember, the LCD includes all the factors all together. So that's right, David. The LCD is exactly x squared plus 4, x squared minus 16, which is x plus 4. Both of them have x plus 4s in them. But the only thing that's missing is the x minus 4 for the first denominator. So that's why the LCD is x squared plus 4, x minus 4. X plus 4, x minus 4. That's step number 1. So I found it. Great. Step number 2 now is what? Make the denominators the same. So I got x over x plus 4 minus 4 minus x over x squared minus 4, minus 16. The thing is, this denominator is already the LCD. It's already that. This is already LCD. Since it's already LCD, I don't need to do anything to this one because it's already the LCD. But this one, you do need it. This one does need x minus 4 to be multiplied. So now when I multiply the denominators for these fractions here, I get x minus 4, x plus 4. But I also had the same thing here. So now the denominators are the same. I did it. And then I have x times x minus 4. So I did number 2. And then step number 3 is what? Move all the make the fractions into one single fraction with the same denominator. Now, the only thing I beg of you to do is this next step. So this is please do this. Because if not, you'll get the wrong answer every time. When you subtract, please put parentheses around the second numerator. So please, I beg of you, please put parentheses around the second numerator. Why? Because if I don't, what people normally tend to do is this. They do minus and they do a minus 4 and they completely forget about this minus x. And they don't realize that this minus also is subtracting minus x. So in a sense, what are we doing? We're distributing a negative 1 to each term in the second numerator. So this goes all the way back to subtracting polynomials. We subtract polynomials by negating the signs of the second polynomial, which is what we're doing right here. But a lot of people tend to miss that step every time. So this should be x squared minus 4x. This should be plus 4. This should be plus x. And then we get x minus 4, x plus 4. And then when we combine like terms, what do we get? We get x squared minus 3x plus 4 all over x minus 4, x plus 4. Okay? Now the question becomes, can I complete step number 4? Is the top numerator factorable? Is it factorable? And I made a silly mistake myself, guys. I don't know if you guys noticed this, but I literally just told you have to distribute the negative, and I did not distribute the negative. Look at me. Subtract by 4. Okay, this should be -4, not +4, but it should be a positive x. Now, can I factor this? Now, this one, yes, I can. The other one, I couldn't. So then what multiplies to -4 but adds to -3? It would have to be what? X minus 4, x plus 1. This is x minus 4. This is x plus 4. And then what cancels out? X minus 4 cancels out. X minus 4 cancels out. And what do I get? I get x plus 1 all over x plus 4. And that is my final answer. So that's how you subtract rational expressions, which is really just adding, but now you have that little step that you have to be careful with, which is to distribute that -1 to the second numerator. A key aspect, a concept here is the LCD. You have to know how to find the LCD if you have two different denominators. And then what are the following steps to make the denominators the same so that you can combine the numerators together, and then see if you can factor to simplify. And if you can, do so, and you get your final answer. So that's how we add and subtract rational expressions.